Hello students, welcome to iQuanta. Today we are going to discuss 11th set of iLRDI series, and this set is from CAT 2021 third slot. Some instructions has been given, such as each of the bottles mentioned in this question contains 50 ml of liquid. So volume is fixed, which is 50 ml. Remember this. The liquid in any bottle can be 100% pure content or can have certain amount of impurity. So pure content percentage is denoted by P and impurity is denoted by I. Visually, it is not possible to distinguish between P and I. There is a testing device which detects impurity as long as the percentage of impurity in the content tested is 10% or more. So basically, if purity is less than equal to 90% or impurity is greater than equal to 10%, the device will be able to detect the impurity, otherwise it's not. Now example has been given. For example, suppose bottle 1 contains only P and bottle 2 contains 80% P and 20% I. If the content from bottle 1 is tested, it will found out that it contains only P, okay, because it's 100% pure. Now if content of bottle 2 is tested, the test will reveal that it contains some amount of I, not the exact amount, but it will contain that it contains some amount of I. Why? Because impurity is 20%. Now another example is given. If 10 ml of content from bottle 1, so let's take two bottle 1 and bottle 2, the purity percentage has been given. So in bottle 1 it's 100%, in bottle 2 it's 80%. Now it says that if we take 10 ml from bottle 1 and 20 ml content from bottle 2. So what will happen if we mix these two? The overall percentage will be, can we say 10 ml of 100% will be 10 and 20 ml of 80% will be 16, right? So total 10 plus 16 out of 10 plus 20. So this will be the exact percentage of purity, which is 26 upon 30 into 100. We can say that this is less than 90%. So it says the test will show that mixture has impurity because purity is less than 90%. Now second example is given, which is if bottle 1 5 ml. So let's take 10 ml from bottle 1 and 5 ml for bottle 2 has been taken. What will be the purity percentage of this mixture? Can we say 10% of 10 ml will be 10 plus 80% of 5 ml will be 4. Total volume will be 10 plus 5 into 100, which is equal to 14 upon 15 into 100. That means this is greater than 90%. So the test will not detect any impurity in the resultant mixture because the purity percentage is more than 90%. I hope this is clear, all these concepts. These are the questions given. 4 questions were there, very easy to solve. Let's move on to these questions one by one. It says 5 ml of content from bottle A is mixed with 5 ml of content from bottle B. The resultant mixture when tested detects the presence of I. Means impurity level is more than equal to 10% or purity level is less than equal to 90%. If it is known that bottle A contains only P, so once again we are going to do the same exercise, bottle A and bottle P. Now it's given that purity percentage in bottle A is 100%. Bottle A contains only P, so 100% pure. What best can be concluded about the volume of I in the bottle B? So let's say purity percent of bottle B is X%. Okay. So if you take 5 ml content, okay, let's take 5 ml content from both of these. Let's take 5 ml from here let's take 5 ml from here. So these are equal volume, we are taking equal volume. So can we say the resultant will be just average of this? So 100 plus x by 2. This should be, this is what? This is purity percentage. This should be less than equal to 90%, right? So from here we can say 100 plus x should be less than equal to 180, or x should be less than equal to 80. So the purity percent of bottle I is less than equal to 80%. Can we say the impurity percentage in bottle B must be greater than equal to 20%? Now what's the volume? Volume of bottle B, it's given initially that it was 50 ml, right? So 50 ml into 20%, this is 10 ml, right? Can we say the least impurity must be 10 ml? So answer is option A, 10 ml or more. Next question. It says there are 4 bottles. Each bottle is known to contain only P or only I. They will be considered to be collectively ready for dispatch if all of them contain only P. In minimum how many tests is it possible to ascertain whether these 4 bottles are collectively ready for dispatch? So what do we know is we have 4 bottles. Bottle 1, bottle 2, bottle 3 and bottle 4. Now all of these bottle contains only P or only I. So we can say these are the cases possible that all 4 bottles are P, contain only P, or 3 of them contain P, 1 of them contain I, then P, 2 bottle contains P and 2 bottle contains I, 1 bottle contain P and rest of them contain I, or all of them contain I. Now we don't know which of these combination has been given, okay, but we need to know that in how many tests is it possible to ascertain whether these 4 bottles are collectively ready for dispatch. Now let's try to understand how is this possible. Can we say if this is the case, if we check, if you take the equal volume, now that volume could be anything, 1 ml, 2 ml, 5 ml, 10 ml or anything, any equal quantity if we take from all these 4 bottles and we test. So basically it will be P percent, yani ki whole pure, it will be 100%, right? 400 by 4, it will be 100% pure, and the device will tell us that this is ready for dispatch. If this is the case, if 3 bottles are pure and 1 is impure, what will happen? So 3 bottles 100 plus 100 plus 100 plus 0 divided by 4. So result is 75%. So if this is the combination given, the device will tell us that this combination, okay, has impurity, right? Because the purity level is 75%, so impurity must be 25%. So this is not ready for dispatch. In this case, if we say it will be 200, 100, 200, 0, 0. So 200 upon 4. So this is 50%, and in this one it will be 100 by 4, which is 25%, and in this one purity level will be 0%. So it doesn't matter whichever combination has been given. In these 4 cases, the device will tell us that it has impurity and this combination is not ready for dispatch, and in this combination it will tell us that it's pure and it's ready for dispatch. So it doesn't matter which combination has been given. In only one test, the device will test us. The device will tell us that these 4 bottles are ready for dispatch or not. So what's the answer? Answer is in only one. In only one test. Okay. Now question number 3. Question number 3, it says there are 4 bottles. It is known that 3 of these bottles contains only P, while the remaining one contains 80% P and 20% I. What is the minimum number of tests required to definitely identify the bottle containing some amount of I? So once again, let's take that there are 4 bottles, B1, B2, B3, B4. 3 of them, it is known that 3 of these bottles contain only P. So P, P, P. Only P means 100% P, okay? While the remaining contains 80% P. So it has impurity. How much? 80%. So this is 100, 100, 100 and 80. Okay. Now we need to tell in some way that in minimum how many tests which bottle has impurity. Now it's impossible to distinguish just by seeing them. So we need to do some test, right? And what do we do here? So one of the basic way is to test each bottle one by one, right? What we can do, we can test bottle 1 at first. If it is pure, we will try again. If it is pure, then we will try once again. And if we try all 3 and all 3 are pure, then we know that exactly one bottle contains impurity. So the rest 4th bottle must be impure, right? So 3 tests needed to be done, but it says minimum, right? It says what is the minimum. So let's try to understand if we can find out this in lesser than 3 tests. Okay, so we can take a combination of 2 bottles, right? What we can do, so there are 2 different kind of bottles, either they are pure or pure and impure. So let's try to take 2 bottles at once. Let's take 2 bottles which are pure. Now if we take equal quantity of liquid content from these 2, if we test, it will tell us it's pure. So now we know that in rest of the 2 bottles there is 80% purity and 20% impurity. So what we can do, we can try bottle 3. If we try bottle 3 and it's pure, then we know that 4th bottle is impure or it has 20% impurity. Or it's also possible that we try bottle 4 at second time and then we get that bottle 4 is impure. It has 20% impurity. So we can definitely find it in 2 ways. Now apart from this, there are also a possibility that we choose these 2 bottles first, out of which one is pure and one is impure, or it has some impurity. Now if we test these 2, if we take equal amount of liquid from these 2 and we test it, what will happen? So just simple average 100 plus 80 by 2, it will has 90% purity or 10% impurity, right? 90% and with 10% impurity, the device will tell us that it's impure. So now we know that one of these 2 bottles has 20% impurity. Now we can test any of these 2, either B3. If we take B3 and test the liquid from it, it will tell us it's pure. Then we know that bottle 4 is impure. Or we can test B4 first, then it will tell us that bottle 4 is impure. So in both cases you can see there are 3 different kind of cases that we can start testing these, okay? Bottle 1, bottle 2 first and then one of bottle 3 or 4, or bottle 3 and bottle 4 first and then one of bottle 3 and 4. So in any case, minimum 2 tests we can say that which bottle is impure. So answer is 2 for this question, okay? Question number 4, it says there are 4 bottles. It is known that either 1 or 2 of these bottles contains only P, while the remaining ones contains 85% P and 15% I. What is the minimum number of tests required to ascertain the exact number of bottles containing only P? So once again, what we are going to do is we are going to take 4 bottles, bottle 1, 2, 3 and 4. So what is the possibility? It says either one or two of these bottles contains only P, either one, while the remaining ones contains 85% P and 15% I. So what we can do, that one bottle contain 100% P and rest of them contain 85% P, or two of these bottle contain 100% P and rest of the two bottles contain 85% P. Either one or two of these bottles contain only P, right? Now it says what is the minimum number of tests required to ascertain the exact number of bottles containing only P. Now once again, if we take equal amount of liquid from this combination and we test it, what will be the percentage of purity here? So it will be 100 plus 85 plus 85 plus 85 by 4. How much is this? This will give us 355 upon 4. So this is less than 90%, right? This is less than 90%. And in this case, if you test it, it will be 100 plus 85 plus 85 by 4, which is equal to 370 upon 4, which is greater than 90%. So what we know, out of these 4 bottles, if we take equal amount of liquid and if we test in the first case, it will tell us that the bottle has some impurity. So we know that it will have 3 bottles which has impurity. But in this case, in the second case, if we take equal amount of liquid and test it, then it will tell us that the given liquid has no impurity, it's pure, right? So but we know that it's given in the question that either one or two bottles contains only P. So we will be certain that this is the case where 2 bottles contain P and in the first case 1 bottle contains P. So in only one test we can say which of these cases has been given. Once again, what's the answer? Option A, which is 1 test. So with this we are done with this set, and I'll be back with next set of iLRDI series. Keep solving questions. All the best for your exams. Thank you.